coming to the second order system. What is second order? So we know the order of the system, which means there are two poles in the system. Let us take this block diagram, and this is the standard block diagram or prototype block diagram for the second order system. Now it is a closed loop. So I have a summing point and there is your forward path transfer function. We have feedback. Again, we are taking for simplicity purpose unity feedback, R of s, C of s, and feedback. This is the G of s. What will be the G of s here? The G of s here will be omega n square by s into s plus 2 zeta omega n. Omega n square by s into s plus 2 zeta omega n is your G of s. H is anyway, it is 1. So for this closed loop system, let us find out what is the open loop transfer function. You know what is open loop, how to find it. That will be your G and H. So your GH is omega n square by s into s plus 2 zeta omega ns. And again for this open loop transfer function, we can say what is the type of, what is the order. So type 1 order 2. So this open loop transfer function is type 1 order 2. Now we can find out the closed loop G by 1 plus GH. If you do that, your C of s by R of s, it is going to be omega n square by s square plus 2 zeta omega ns plus omega n square. Omega n square is a numerator and denominator is s square plus 2 zeta omega n plus omega n square. So this is a very standard second order closed loop transfer function. We know the definition of the characteristic equation. The characteristic equation is the denominator is equal to 0. Whenever you make denominator is equal to 0, so that equation is the characteristic equation. Even the second order transfer function also we can find out characteristic equation. So your characteristic equation is s square plus 2 zeta omega ns plus omega n square is equal to 0. We know the importance of the characteristic equation. We can find out the closed loop poles. So the roots of second order, the roots of the characteristic equation are closed loop poles of the system. Now if you look at what are the different terminology or what are the different parameters we have in this transfer function. The first one is zeta. The name of the zeta is damping ratio. So basically it is a ratio. What is the ratio? The ratio is of actual damping by critical damping. What is actual damping? We will see that the actual damping term is zeta omega n. The critical damping term is omega n. So therefore the ratio will be zeta. So there are no units for this ratio. Similarly, I have another term which is omega n. The name of omega n is called undamped natural frequency, and the units are radian per second. Both are very important terms when it comes to any physical system, damping ratio as well as undamped natural frequency. So with this characteristic equation, then we can find out the poles or we can find out the root location on S plane. So to understand a second order system, let us take a series RLC system, a physical electrical system. Now series RLC system, R, L and C, and its equivalent Laplace domain is R, Ls and 1 by Cs, and input is given here, that is Vi of s, and output I am taking at the capacitor V0 of s. Now, so transfer function we can obtain very easily because it is a single loop problem. Therefore, I can use a voltage division method, that is a V0 of s divided by Vi of s is Z2 divided by Z1 plus Z2. So Z2 is 1 by Cs and Z1 is R plus Ls. Then we can substitute here to get the transfer function. Then if we substitute, we will get V0 of s by Vi of s is, we will get it very easily as 1 by Lc divided by s square plus R by Ls plus 1 by Lc, because I want to write in the standard form. So if we write in the standard form, 1 by Lc divided by s square plus R by Ls plus 1 by Lc. So this is my transfer function of the electrical system, series RLC system. Now take the characteristic equation of this transfer function and compare with the characteristic equation of the standard system. What is the standard characteristic equation? S square plus 2 zeta omega ns plus omega n square is 0. Now what is the electrical system characteristic equation? S square plus R by Ls plus 1 by Lc is equal to 0. When you compare these two, then you can find first omega n. What will be the omega n? This is omega n square 1 by Lc. So omega n is 1 by root Lc. We know from the circuit theory, at resonant condition, then we will have the resonance for the natural frequency omega is 1 by root Lc. Therefore here also this system has a natural frequency omega n is 1 by root Lc. So omega n is now the natural frequency of the system. Omega n is the natural frequency of the physical system. Now when you write zeta, zeta is nothing but R by 2 root C by L. R by 2 root C by L. So this is a formula for your damping ratio. So omega n damping ratio we can find out like this for any physical system.